Hello everyone! So in this video, we're going to be doing a little physics, okay? And I might be thinking that this is a calculus video, but especially in these types of problems, okay, physics and math are closely related. And that is the motion problem. Okay, it's very popular on the AP test, okay? And we're gonna have to dig into some physics. Okay, so usually on the AB exam, the BC exam version of the motion problem we'll do a bit later, okay? But this is for the AB exam. Okay, and it's good for everyone to know because it helps with definitions. So let's say you're on a singular axis. Okay, usually the x-axis they give you. Although sometimes they do ask you on the y-axis, but let's keep it x-axis for simplicity. Okay, so the position, okay, if you're on like a x-axis, like number line, the position of a particle, they usually ask you about particles, is the x-coordinate, right? It is a location. Okay, so the position of this particle is 2. The position of this particle, let's say, is -3. Okay, so positions mark locations. Okay, so this is position. Now, velocity is the rate at which position changes. Okay? You might remember from physics, it's displacement over time. Okay, so velocity in motion problems like this is the rate at which position changes with respect to time. And if you write as a derivative, you get dx dt. Okay, the derivative of x, and where x is our position, with respect to time. Okay, so velocity is the derivative of position. The derivative of position with respect to time. Okay, now acceleration is also another physics word. Acceleration here is the rate at which velocity changes with respect to time. So if velocity was v of t, then the acceleration is dv dt. Okay, and because it's the derivative of the velocity, and velocity is the derivative of position, acceleration is also the second derivative of position with respect to time. Okay, so this is the derivative of that. Velocity is a derivative. Acceleration is a derivative of velocity. Okay, so acceleration is the derivative of velocity. Okay, now you have to realize that there's another quantity that you have to be familiar with: speed. And speed, if you remember from physics, is not a vector quantity. If you remember what a vector quantity is, let's review it. A vector quantity is something that has both magnitude and direction. Okay, so like a physics definition. So basically, in math terms, if you have the velocity is v of t, speed is the absolute value of v of t. Okay, because speed does not have a direction, speed cannot be negative. Okay, because if velocity is negative, that numerically tells you the direction it's going. Okay, because if we define positive as rightward and negative as leftward, if positive is right and negative is left, if the velocity is negative, then you can tell that the particle is moving to the left. Otherwise, it is moving to the right. With speed, it just tells you how fast the particle is moving, regardless of direction. So the speed is the absolute value, because absolute value is always positive. So speed is the absolute value of velocity. Okay? And distance is the total length that the particles traveled. Okay, and we define it in calculus in a specific way. Okay, so we'll get to that a bit later. Okay, but right about now. Okay, so let's look at we looked at the relationship between velocity, acceleration, and position. There's also another relationship. Okay, because velocity is the derivative of position, what is position with relation to velocity? Well, position is the integral of velocity because velocity is a derivative of position, and derivatives and integrals, they're basically, opposite operations. So like inverse operations. Okay, so if velocity is a derivative of position, then position is the integral of velocity. And the same thing can be said about acceleration. Because acceleration is a derivative of velocity, velocity is the integral of acceleration. Okay? And you can sort of make a similar argument. Okay? Speed is, if you remember from physics, is the distance over time. And you could write that, if you were to use calculus, as the derivative of distance. So distance is the integral of speed. Okay? So the integral of speed with respect to t, with respect to time. So with all these definitions, we are going to do a practice problem. It's going to be a bit easier than the ones that the AP people usually give you, but this is just to serve as a practice. Okay, so let's say you have a particle and it moves on our x-axis with velocity, and the velocity as a function of time is given by 3t cubed minus 2t squared plus 6. Okay, this is the velocity the velocity is a function of time. So we're going to ask a couple of questions. A, is the speed, when is the particle moving to the right? Okay, it's moving on the x-axis. And we're going to define right as positive and left as negative. Okay, the particle moving to the right is the speed increasing at time t equals 1. When does particle change direction and the position at time t equals 2? Okay, and they give us that the position at time t equals 0, it initially starts at position 3. Okay, so let's tackle this. So when is the particle moving to the right? So if the particle is moving toward the right, that means the velocity is to be positive, right? That because the velocity is the derivative of position. Okay, it's the rate at which position changes. So if velocity is moving towards the right, then the position is increasing. Okay, so then if you increase, you go more positive. Okay, you get more and more positive. So you're moving toward the right. Okay, intuitively that makes sense. If you think about what we defined as right and left, positive and negative. So we just need to find an interval where v of t is positive. Okay, so v of t must be positive. So we're gonna use a calculator for this one. Okay, because this equation can't really easily be solved. Okay, so we want to find where v of t equals 0. We want to find critical numbers. Because if we find critical numbers, you can easily divide the interval into regions of increasing and decreasing. So let's solve this. Okay, so 3t cubed minus 2t squared plus 6 equals 0. All that for t. What do we get? We get as okay, so we get a negative t, which does not exist. We can't have a negative time. So first for time t is greater than or equal to 0. Okay, it's implied. So now we see that there are no times that it changes direction. So we can easily answer part C. So at no time in the interval, no time during this particle's journey does it change direction. So is the particle always increasing or is it always decreasing? Is the velocity always positive or is it always negative when t is greater than 0? So we can just test out t equals 0, okay? Because since we see that there are no positive zeros of our function v of t, that means it must be on one side of the axis, okay? It must be on one side of the axis. Okay, it must be on one, either the top or the bottom. So it must be positive or all negative for t is greater than or equal to 0. So if we test out, we can easily do a test. We see that it's always, for t equals 0, it's positive. And since there are no zeros, it will never become negative. So for all t, we answered part A and C quite easily. So is the speed increasing at time t equals 1? Okay, is the speed increasing? And usually this becomes a trick question, okay? Because is the speed increasing? So if the speed is increasing, let's find v prime of t, is equal to a of t, or acceleration. Okay, so if we take the derivative of velocity, we get 9t squared minus 4t. Okay, and at t equals 1, we get 9 minus 4, so a of 1 equals 5. That means the speed is increasing because acceleration, okay, the acceleration is making this velocity more and more positive. Okay, so yes, it is increasing. Okay, so what happens if acceleration was negative? Okay, what happens if our acceleration was negative? Well, that means our speed is decreasing, okay? Our speed is decreasing. Even though the velocity does not become negative, our speed does start to decrease. Why? Because if you have a particle moving this way with the velocity, it's getting pulled back by the acceleration, sort of like physics terms. Okay, so it's getting pulled back, so it'll start to go slower and slower and slower until it starts to go this way. Okay, and even if it's the particle is moving to the left, so velocity is negative and acceleration is negative, that doesn't mean it's slowing down. Even if it's getting more and more negative, that doesn't mean the speed is slowing down. The speed is decreasing. Because the acceleration is moving in the same direction as velocity, the magnitude of velocity, okay, the actual speed of the particle increases. Okay, so you have to remember this distinction. And when we do a practice AP problem on this distinction becomes very clear. Okay, so the speed is increasing. So let's look at part D, the position at time t equals 2. We're given that the position at time t equals 0 equals 3. Okay, so the position is equal to the integral velocity. So we take a definite integral of v of t dt, that is equal to x of 2 minus x of 0. And you might see what we're about to do. We're going to solve for x of 2. So you have x of 2 equals x of 0 plus the integral from 0 to 2 of v of t dt. And because x of 0 is equal to 3, they give us this information. They give us velocity with as a function of time. This becomes a kind of easy integral. Okay, so we have 3 plus, well, that gives us 3t to the 4th over 4 minus 2t cubed over 3 plus 6t. So this expression is 0 when t equals 0. So we only need to evaluate it at t equals 2. So you have 3 plus 2 to the 4th. Okay, so 3 times 16 over 4 minus 2 times 8 over 3 plus 12. So this cancels. So we have 3 plus 12 minus 16 over 3 plus 12. So we have 27 minus 16 over 3. So that's 81 over 3 minus 16 over 3. And that becomes 65 over 3. Yes. 65 over 3. So we get that the position at time t equals 2 equals exactly 65 over 3 at that instant. And we're done. Okay, this problem is a bit easier than the ones in the AP exam, but it shows you how position, velocity, acceleration, speed, and distance are all connected. Thanks for watching. Okay, and by the way, at this video, we're officially done with all the AB curriculum. Okay, we are done with everything you need to know for AB, which means from this video forward, it will all be BC stuff. Okay, so all the videos after this video will be BC. Okay, thanks for watching. If you have any questions, please comment, like below, okay, and subscribe to our channel for more incredible videos. Thanks for watching.